Have you ever wondered how you find that one perfect needle in an ever-growing haystack of information? Well, today we're going to dive into the really clever, foundational concept that makes it all possible, the document surrogate. I mean, really think about it. Every single time you search for something online, you get hit with this avalanche of results, right? It is literally impossible to read everything. So how in the world do you decide which link to click, which paper to download, or which book to even open? This is the fundamental challenge of information discovery. So here's our game plan for today. We're going to start with that problem, the ocean of information. Then we'll define what a document surrogate actually is. After that, we'll look at its key parts, the abstract and the index, see a real-world example from way back when, and finally, connect it all to the AI tools that we use every single day. Okay, let's set the scene. As the 20th century rolled on, the sheer volume of published information just exploded. It created this monumental challenge. How could scientists, researchers, or really anyone possibly keep up with all the new developments? The problem then, and the problem now, is discovery. What we all need, fundamentally, is a shortcut. A reliable way to get the gist of a document super quickly, to decide if it's even relevant to us without having to invest hours reading the entire thing. We need to be able to judge the content's value pretty much at a glance. And that shortcut, that handy little stand-in, well, it actually has a formal name in information science. It's called the document surrogate. And here is a fantastic definition straight from a 1974 U.S. Geological Survey guide. A document surrogate is a representation of the original. So what does that really mean? The key thing here is that it's not the document itself, but a smaller, much more manageable version. It's specifically designed to be easily stored, searched, and used to help people like you and me find the original. Honestly, the best analogy I can think of is a movie trailer. The trailer gives you the plot, the main characters, the vibe, all in just 2 minutes, right? So you can decide if you want to see the whole movie. A document surrogate does the exact same job, but for a piece of text. All right, so let's break this down. The first and probably the most familiar part of a document surrogate is the abstract. You can think of it as the narrative component, the story in miniature. The whole goal of an abstract is to give you a super precise and concise summary. It has to be descriptive enough from the author's perspective, but also representative enough from the readers to let you make a quick call on whether the document is relevant to you. And you know, not just any summary will do. A good abstract has to check a few really important boxes. It's got to be accurate. It has to represent the original faithfully. It needs to be self-contained so you can get it without reading the full paper. It has to be concise, but also specific. And this is crucial. It should be non-evaluative. It just reports. It doesn't judge. And of course, it has to be coherent and easy to read. But a summary isn't enough, right? How do you find that amazing summary inside a massive database? Well, that's where the second part of the surrogate comes in, the science of indexing. This is how we make documents discoverable in the first place. So the first type of index term is called a descriptor. The best way to think of these is as official, pre-approved tags, kind of like the ancestor of a hashtag. They come from a controlled vocabulary, a thesaurus, which makes sure everyone is using the exact same term for the same concept. And that consistency, it is absolutely vital for a good search. But what about new ideas, or super specific place names, or brand names? Science moves fast, and a thesaurus can't always keep up. That's what identifiers are for. They give you the flexibility to add those crucial keywords that aren't on the official list yet, capturing the unique essence of a document. So you've got all these keywords. How do you signal which ones are the most important? Back in 1974, they had a really simple, elegant system. The asterisk. By marking the most central terms, you weight them. You're basically telling the search system and the user what this document is really about. All right, that's enough theory. Let's see how all these pieces, the abstract, the descriptors, and the identifiers, all come together in a real-world document surrogate from that 1974 guide. This is the fun part. Take a look at this. This is an input transaction form. Now I know, it might look like some old-school bureaucratic paperwork, but it's actually a perfect, self-contained document surrogate. This one page has everything you need to represent a scientific article for a computer database back then. Let's zoom in a little. Right here, in box 16, that's the abstract. It's summarizing a study on a pollutant in Escambia Bay, Florida. And notice the rule, not to exceed 200 words. This forces the writer to be concise and specific, just like those qualities we talked about. Okay, now look at box 17A. These are the descriptors. You can see these official-sounding terms like bioassay and toxicity. And do you see the asterisks next to water pollution effects and bioindicators? That's weighting in action. It's signaling the core topics of the paper. This is basically the manual version of what Google's algorithm does billions of times a day. And right below that, in box 17B, are the identifiers. Escambia River is a specific place. Arachlor 1254 is the specific chemical they were studying. These are way too specific for the general thesaurus, but are absolutely essential for finding this particular document. This form right here is the whole package. So that form was from almost 50 years ago, filled out meticulously by a person. Today, we use AI to do pretty much the same thing, create a stand-in for a real document. The fundamental goal hasn't changed one bit, but the tools, wow, the tools are radically different. Modern AI summarization really comes in two main flavors. You've got extraction-based, which is kind of like a computer skimming an article and just pulling out the sentences it thinks are most important, word for word. Then you have abstractive-based, which is way more advanced. The AI reads and actually understands the content, then generates a completely new summary in its own words. A lot like that human who carefully wrote the abstract back in 1974. The principles totally endorse. And this brings us to a really fascinating final thought. The document surrogate was originally designed to lead you to the original text. But as abstractive AI gets better and better, we have to ask ourselves, if the surrogate becomes a perfect representation, will we still even need the original at all? It's a question I think we're all going to be answering very, very soon.